Hello everyone, and thank you for attending my talk on building a peer-to-peer darknet lessons learned. On a personal note, I'm very happy to be here today. 2 years ago it wasn't so certain because I had the misfortune of tearing a muscle in my thigh. So I would really just like to thank the pharmaceutical industry for my presence here because painkillers are really awesome. But in case I limp or I slur the words, you know the reason why. So my name is Ernir Erlingsson. I'm Icelandic, and I've worked more or less for 8 years as an Android developer. Although more recently, I've actually rejoined academia, and I'm working on a PhD in machine learning and high-performance computing. But that's not what I'm going to talk about today. Today, I'm going to talk about a project that I joined 2 years ago, which is called the Briar Project, and it's all about secure messaging. So let me just break it down for you. So the Briar project is a free and open source software project. And given that it suffers from all of the same things that free and open source software projects suffer from, it's not, we have sporadic funding, and it's like what I say, it's like the mind is willing, but the body needs food and shelter. So we've been trying to work on it as much as possible, but unfortunately, the funding hasn't really covered us to work on it full time. But we have a really committed team, which I will introduce to you also shortly. We have an Android application, but it's not only exclusive Android application. Briar project is really thought to be a platform independent, or like existing on many platforms. But Android is like the first platform that we target. The slogan of Briar is secure messaging everywhere. But what really sets Briar apart, the Briar application, from other messaging applications, is that the focus is fully on security and privacy. So the thing is, there is actually a trade-off between security and usability. Now, most messaging applications, they want a lot of users, so they put the focus on usability, and then they try to make it as secure as possible. Briar is really not about that. Briar is not trying to be the next WhatsApp. Briar is just trying to create the most secure messenger. That you, see how secure you can make it. And it's quite unique in its own way. It's like a unique amalgamation of methods to ensure privacy and security. And today I'm going to talk to you about some of those methods that Briar is employing, including peer-to-peer networks and darknet. So I just want to do a short shout out to the team, which is really awesome. I have the privilege of working with really smart people. There are a lot of PhDs there and a lot of people from all over the world. I haven't actually met most of these people, but it's been really fantastic to work with them. Brazil, New Zealand, Germany, England. It feels really great to be working on a team so international. It's a lot of fun. So just Michael Roger, the topmost name, is actually the founder of the project. And he has worked on it the whole time. The project, Briar project, started as after his thesis on secure messaging. And I had the privilege of meeting Julian Dem. He's actually sitting here right now. And we also have countless more people that predate me, and countless people that are coming and doing a little bit of work and then leaving again. And actually, there was another speaker today, Markus Ligi. Is he maybe here? Who also has been really helpful. So the financing that we do have in the Briar project is, I want to talk a little bit about this because I think the portfolio is really great and speaks for the project. So among our supporters, we have organizations and funds that support privacy, open source software, and digital rights, and stuff like that. So I'm really proud of this portfolio. Okay, let's get down to business. So I want to talk about three methods that Briar is using to protect the user's data. Now, the first is end-to-end encryption. But a few years ago, this would have been something special, but today this isn't really special anymore. I mean, WhatsApp even has end-to-end encryption. So I'm going to focus on the other two aspects. So the end-to-end encryption that Briar uses is asymmetric cryptography, quite standard stuff. But Briar also uses peer-to-peer communication. So just to explain a bit what that means is that here's like this is the classical centralized approach between a client and a server for a messaging app. So Alice sends Bob a message, but she actually sends it to a server which then relays it to Bob whenever it is convenient for Bob to receive this. He maybe gets a notification and then the message is loaded. Whereas a peer-to-peer network is really just circumventing the server completely and sending the message directly to Bob through the network. So this really is a good example of the trade-off that I mentioned before, the trade-off between security and privacy. No, security, sorry, and usability. So when you have a server, it's much more usable. The server can store your message and simply wait for Bob to come online, and then he sends the message to him. Bob can even switch devices, and there's not any problems with that. He can always get his messages, all of them. Whereas the peer-to-peer network is decentralized, which means that the message can only be sent when both parties are online. And switching devices and stuff like that is problematic. It's not impossible, but it's problematic. Now, this can be mitigated in some ways, but it's always at the cost of security. For example, if there's a mutual friend, then that mutual friend could maybe get the message and hope that he or she can relay it when then Bob comes online, if Alice is not online. But this is really leaking data. This is revealing relationships between users and stuff, leaking metadata, which is something that Briar is trying to avoid at all costs. So coming back to this, the third method that Briar is employing is Darknet. So it's using a peer-to-peer network, and the transmission over the mobile network are all through Darknet. So what is a Darknet? There's a Wikipedia definition of a Darknet. But basically, Darknet is actually an old term from the 80s. It's an old terminology, basically just in the dark. It doesn't want to be seen there and be visible. And therefore, and today for me, this fulfills two things, the terminology Darknet. It makes it sound suspicious to normal people, which is why it's used by some parties. And it sounds a bit cool to developers, at least some developers. So that's my theory on why this is so popular today. Now, the most widely known Darknet is Tor, which is a privacy network. There are also some file-sharing darknets that exist, but Tor defines itself as being a privacy network. And you maybe have heard about the Tor browser, which I understand actually 1 million people around, give or take, are using the Tor browser for privacy reasons. But what does Tor stand for? Is it a hammer-wielding Norse god fighting the good fight for privacy? No, it's the onion router, but you probably knew that already. So it turns out that onions are actually a pretty good description of how Tor works, because Tor is all about layered encryption and decryption, much like an onion. So Tor is divided into the computers that have the Tor services they're called hidden services. And Tor provides anonymity, which I will explain in a moment. So just roughly how Tor works. If Alice is sending Bob a message through the Tor network, so Alice is here, first Alice has to receive, first Alice gets the all the hidden services, gets information from the internet about all the hidden services, and then plots a randomized path or some path with arbitrary number of hidden services to send the message to Bob. Alice constructs an onion, which basically means this layered encryption, and using the public key from the different services. And then Alice sends the message to the first service, which then takes the first layer off, and then sends it further. So each hidden service always takes one layer off, and each hidden service only knows about the previous point and the next point, and they also don't know the nature of those points. Is it another hidden service? Is it actually Bob? Is it Alice? And therefore, if there's a man-in-the-middle attack, if somebody is like grabbing all of this communication and trying to see who's talking to whom, he will probably only see these two computers in the Tor network that are basically sending messages to each other. So the anonymity of the sender and the receiver is protected. So what about Tor and Android? The problem with the Tor network is that it isn't really built with mobile in mind. So when you implement Tor on Android, it really drains the battery because it relies heavily on the CPU, because Tor runs tasks every single second. It's checking the hidden services, updating it, and the path you have chosen to send the messages there's a lot of stuff going on. We've been trying to circumvent this, but we're basically using a wake lock as well on the app, just to keep Tor running. Because if Tor disconnects, you have 100 seconds to reconnect. If for some reason you drive through a tunnel or for some reason your device loses connectivity, you have 100 seconds. Otherwise, you have to really start from scratch, which is an expensive operation, takes a lot of time, energy, etc. So if this is so difficult, why is Briar using Tor? Well, it's because of the anonymity. Tor is protecting your metadata. And to remind you what metadata is, it's not the content of a conversation or communication, it's who's talking to who, when, where, etc. But is this data really important, the metadata? Well, it's pretty important. It turns out that, according to this general, the US government is killing people based only on metadata. Now, this is, of course, very dramatic. I'm being very dramatic right now. But what this does, this speaks volumes for the amount of information that can be extracted from metadata. So let's go to the good stuff. So let's take a look at some code and how Briar is using Android. So first, I want to give you a short code overview. So at the moment, Briar is divided into 3 different modules. The foundation module we call Bramble, and it takes care of all of the transport layers here on the bottom. We have all the grayed out cells is stuff we haven't done yet. So we haven't. We intend to implement Wi-Fi Direct and I2P, which is another type of darknet. Not onions there, it's actually garlics. But so we have LAN support, we have Bluetooth support, we have Tor. There's a message synchronization layer. Peers is your contacts, and the crypto stuff is performed there in a database, which is also heavily encrypted. And on a side note, I could have probably have talked for 20 minutes only about Bluetooth, because it's really amazing the amount of problems due to device fragmentations and also Bluetooth is sort of a mess. But I'm actually, when it comes to mobile applications, I'm actually pretty old. More than 10 years ago, I was making Bluetooth applications on Nokias and Sony Ericssons and stuff, using Symbian and Java Micro Edition. And I can actually tell you that today it's much better than what it used to be, but it's still difficult, and there are a lot of unexplained drops of connection and difficulties in pairing, which seem to stem from fragmentation. Now, the next module on top of Bramble, and just one more thing, we intend to release Bramble eventually to assist other developers in implementing any of these things into their own app. So you don't have to start from scratch. There's also another library, actually, another application called Orbot, which also connects to Tor, but there you actually have to download a separate application. The next thing is the Briar core, which contains messaging forums, blogs, groups, and our RSS imports. This is all stuff we have right now. We have the Android application, we have a beta version in the Play Store. You can actually download it right now if you want. And we intend to work on a desktop application as well. This is like the next roadmap, so to speak. So what are some of the challenges here? So one challenge is just simply maintaining a messaging service in Android. So remember, because we're using a peer-to-peer network through Tor, we can't really rely on a server who sends us a nice notification or something like that. We have to do it ourselves. We have to poll the network, keep the connection alive. We have to receive the messages and do it all ourselves. So in Android, you have two types of services which can be suitable. You have something called the background service, which can run even though your application is not running. And then you have something called the foreground service, which runs only when your application is running. Now, it would seem that we should pick the background service option, but actually, there are constant operating system restrictions that are due to power savings. So the next generation of batteries can really not come soon enough. I mean, preferably yesterday. So Google is ramping up the control. So in Lollipop, you had the job scheduler, which was recommended at the time. You didn't have to use it. So instead of having a background service, they recommended you should use the job scheduler because it's much more effective when it comes to the power management. Then there was those and standby modes in Android Marshmallow, which actually can kill both foreground and background services. And then finally in Oreo, you actually have real background service restrictions. They force you to use, I think, the job scheduler or something along those lines. So it actually turns out for Briar, we can't use a background service, we need to use a foreground service. But using a foreground service for the secure communication has pros and cons. Okay, it's the good, the bad, and the ugly. The good, it's easy to make a foreground service. You just extend the service class, you add to the manifest what is needed for the service. And I would like to highlight here the exported false here ensures that it can only be used for your application and not any other applications. That's important. And we decided to go for a service that you bind because you can keep that living long in the background. It's not attached to any activity or anything like that. You can just keep it running in the background. And it's really easy to start such a service, and it's really easy to bind such a service, and then you're basically good to go. Then you can receive messages through the network. So what is the bad things about this approach? Well, there's a fixed notification. A foreground service must provide a notification for the status bar. It's just stuck there, and it bothers. It's not really good user experience. It bothers a lot of people. It's not fatal, but it's not so cool either. There's another bad thing. Those must be manually whitelisted. Now, you can assist the user in whitelisting it by adding this to the manifest, and then adding this code would automatically open this whitelist in the settings, which then basically tells those in standby, leave this app alone, let it run so it can receive messages. But the user has to manually say, agreed. And this is really as far as we can go in helping the user do that. Are you ready for the ugly? So, we've all heard about Android fragmentation, right? It's really, I worked on a lot of apps, and sometimes this was really no issue at all, and sometimes this was a big issue. And here it's unfortunately a pretty big issue, because manufacturers, they have a different approach to power management. They have their own stuff. It's not only the operating system, there's also stuff from the manufacturers. So you have different stuff. So for example, UV, what we have experienced with them is that no matter what we do, even though it's whitelisted, and UV actually has another whitelist of their own, so even if it's double whitelisted, 60 minutes max, then they kill the Briar service, running in the background, receiving messages. We're working on it, but we haven't found a solution yet. Sony has something called stamina mode, which used to be much more aggressive before Google started applying their own OS restrictions. But basically, stamina mode, yes, also kills the Briar service. There are probably more, which we haven't discovered yet. We're in the beta phase. We have users that are reporting bugs, and we are expecting that there's probably more, because power management is always becoming more and more of an issue. There are no future guarantees. The next version of Android, the next version of Samsung might make more difficulties for running a secure application like Briar and with a peer-to-peer network. But we're working hard to adapt the code and fixing all of this, and we have actually made great progress on a lot of problems we had due to fragmentation. But there are still problems that remain. Finally, just quickly, there's a user experience challenge that I also want to talk about, the chaotic message delivery. So you have a bit of unpredictable message delivery due to peer-to-peer networks. If Bob doesn't sign in for a month, and then suddenly he signs in, and then you get all of the messages he maybe wrote for a month, or he gets all of yours. And Tor also, Tor does not guarantee order of delivery. You have different paths in sending messages, and they don't all take as long. So it could be that you're actually receiving in the present a message that you were supposed to receive in the past, like before another message that you've already received. So how do you explain this well to the user? This is a real head scratcher that we had, and the best we came up with is basically something like this: arrows that are automatically updated when Briar receives the messages and say like, hey, you have here below you, which is new, you have like 7 new messages, and above you, hey, you have 3. And then you can press it, and then you jump to those locations. So there's a beta version out, and try it, and tell us what you think. Now, I want to brag a bit. We did a security audit before we released the beta version, and it was performed by Cure53, which is actually a Berlin specialist group or team, which performs which penetration tests and security tests of software and applications on the internet and such, and which gave us a great review. So at least when it comes to security, we feel like we're doing something right. You find there's a lot of further information about Briar if you're interested. Some of our team members are blogging about it. We have a Twitter account. Everything is of course online, GitLab. You can look at all the issue tracker. You can look at all the code. You can check our webpage. If you want, you can get involved. You can join the discussion. You can help us with the code. You can become a tester. It's all open to you. You can even add an app translation in your native language, if you're not a non-English and German speaker, that is. So, I hope I kept you entertained and told you interesting stuff. Thank you for listening.